Hello guys! Welcome to my channel, Char. Welcome to BSECE 33 channel. Sumasakit na ba ang ulo niyo sa mga circuits? Marami na ba kayo na-hit na LED? Kung gano'n, nasa tamang video kayo! For today's lesson, let us focus on another important component in the field of electronics, known as a diode. What is diode? The semiconductor diode, with applications too numerous to mention, is created by simply joining an N-type and a P-type material together. It is the joining of one material with a majority carrier of electrons to one with a majority carrier of holes. The basic simplicity of its construction simply reinforces the importance of the development of the solid-state era. Diodes are basic unidirectional semiconductor devices that will only allow current to flow through them in one direction only, acting more like a one-way electrical valve. Ang diode ay two-led semiconductor na nagsisilbing one-way gate sa electron flow. Ang ibig sabihin nito ay pwedeng forward bias or reverse bias depende sa kung paano natin gagamitin ang diode. Ang term na forward biased and reverse biased ay hindi na bago, ngunit marami pa rin sa atin ang naguguluhan kung ano ba ang pinagkaiba nito. Kung nakakonect ang diode sa circuit with its anode sa positive terminal at cathode sa negative terminal ng supply, natatawag ang connection nito na forward bias condition, habang reverse bias condition naman kapag ang anode ay nasa negative terminal at cathode sa positive terminal ng supply. A diode conducts well in forward bias condition, but it cannot conduct in reverse bias condition. Anode, which is the positive terminal of a diode, is represented with capital A, and the cathode, which is the negative terminal, is represented with capital K. Ang diode ay matatawag rin na rectifier. Makikita sa slide na ito ang illustration ng diode, kung saan ang cathode ay ang straight line at ang other end naman nito ay ang anode. Sa pagitan ng P-type material and N-type material, makikita ang region of uncovered positive and negative ions. At ito ay tinatawag na depletion region, dahil sa pag-reduce ng free carrier sa region nito. The term bias refers to the application of an external voltage across the two terminals of the device to extract a response. Sa figure na ito, forward bias ang tawag kapag ang external voltage ay nai-apply sa diode such that it cancels potential barrier at pahintulutan ang pagdaloy ng kuryente. Kung ang anode at cathode ay nakakonect sa positive and negative terminals, respectively, the holes in P-type and electrons in N-type tend to move across the junction. Sisirain niya ang barrier. There exists a free flow of current with this, almost eliminating the barrier. Dahil sa repulsive force na ipinoprovide ng positive terminal sa holes at negative terminal sa electrons, mangyayari ang recombination sa junction. Ang supply ng voltage ay dapat sobrang laki na magkakaroon ng movement of electrons and holes through the barrier upang mabigyan ng forward current. Ang forward current ay ang kuryenteng na idudulot ng diode kapag ito ay forward biased condition. When an external voltage ay nai-apply sa diode kung saan ang potential barrier nito ay malaki at pipigilan ng pagdaloy ng kuryente, reverse bias ang tawag dito. Baliktad ang pagkonekta ng anode at cathode sa terminals, kaya magiging negative and positive terminals ayon sa pagkakabanggit. The electrons will be attracted to the positive terminals and holes are attracted to the negative terminals, kaya parehas na mapapalayo sa potential barrier, increasing the resistance of the junction and preventing any electron to cross the junction. With the increasing reverse bias, the junction has few minority carriers to cross the junction. This current is normally negligible. This reverse current is almost constant kung ang temperature ay constant. If lumaki pa ang reverse voltage, mangyayari ang reverse breakdown kung saan magkakaroon ng avalanche of current flow sa junction. Due to high reverse current, the device will be damaged. If a p-type and an n-type material are brought close to each other, both of them join to form a junction as shown in the figure below. A p-type has holes as the majority carriers, and an n-type material has electrons as the majority carriers. As opposite charges attract, few holes in p-type tend to go to the n side, whereas few electrons in n-type tend to go to the p side. As both of them travel towards the junction, holes and electrons recombine with each other to neutralize and form ions. Now, in this junction, there exists a region where the positive and negative ions are formed, called as p-n junction or junction barrier as shown in the figure. In figure number 2, the formation of negative ions on p side and positive ions on n side result in the formation of a narrow charged region on either side of the p-n junction. This region is now free from movable charge carriers. The ions present here have been stationary and maintain a region of space between them without any charge carriers. From the figure illustrated below, it can be seen that as this region acts as a barrier between p and n-type materials, this is also called as barrier junction. This has another name called depletion region, meaning it depletes both the regions. There occurs a potential difference Vd due to the formation of ions across the junction called as potential barrier, as it prevents further movement of holes and electrons through the junction. Purpose of a diode. A diode is used to block the electric current flow in one direction, i.e. in forward direction, and to block in reverse direction. This principle of diode makes it work as a rectifier. For a circuit to allow the current flow in one direction but to stop in other direction, the rectifier diode is the best choice. Thus, the output will be DC, removing the AC components. The circuits, such as half-wave and full-wave rectifiers, are made using diodes, which can be studied in electronic circuit tutorials. A diode is also used as a switch. It helps a faster on and off for the output that should occur in a quick rate. A practical circuit arrangement for a p-n junction diode is as shown in the following figure. An ammeter is connected in series and voltmeter in parallel, while the supply is controlled through a variable resistor. During the operation, when the diode is in forward bias condition at some particular voltage, the potential barrier gets eliminated. Such a voltage is called as cut-off voltage or knee voltage. Kung mag-e-exceed ang forward voltage sa kanyang limit, tataas ang forward current at masisirang device due to overheating. The following graph shows the state of diode conduction in forward and reverse bias condition. During the reverse bias, current produced through minority carriers exists, known as reverse current. As the reverse voltage increases, this reverse current increases and it suddenly breaks down at a point, resulting in the permanent destruction of the junction. Here is a water analogy of diodes. When water pressure on left overcomes the restoring force of the spring, magbubukas ang gate at dadaloy ang tubig. But when water pressure is from right to left, the gate is pressed against the solid stop and no water is allowed to flow. Spring restoring force ay mahihalin tulad sa 0.6 volts na kailangan upang ma-forward bias ang silicon diode. Makikita natin sa slide na ito na may dalawang klase ng rectification, ang half-wave at full-wave. Ngunit di tayo magpo-focus dito sapagkat ito ay matatakal sa next lesson. Pero para kayo ay magkaroon ng background, in half-wave rectification, diode converts AC input voltage to a pulse DC output voltage. Whenever the AC input becomes negative at diode's anode, the diode blocks current flow. Diode introduces a 0.6 voltage drop, so output peak is 0.6 voltage smaller than the input peak. A full-wave rectifier does not block negative swings in the input voltage. Rather, it transforms them into positive swings at the output. To gain an understanding of device operation, follow current flow through pairs of diodes in the bridge circuit. It is easily seen that one pair, D1 and D3, allows current flow through the positive VE half cycle of V in, while the other pair, D2 and D4, allows current flow during the negative VE cycle of V in. There are many types of diodes depending upon many factors, such as the frequency used, their working and construction, their applications, etc. Let us go through a few of them. The junction diodes are the normal PN junction diodes but differ in construction. There are three types of junction diodes, as shown in the following figure: rectifier, zener, and switching. Rectifier. These diodes are the normal PN junction diodes which allow current to flow through them in only one direction and stop in the other direction. These diodes are used in rectifier circuits to convert alternating current into direct current. There are circuits such as half-wave rectifier and full-wave rectifier circuits which use these diodes. These rectifier circuits are used in power supply sections of many circuits where alternating input current has to be converted into direct current for that circuit applications. Zener is a special kind of diode which permits current flow not only in forward direction but also in reverse direction. A normal diode, when operated in reverse bias, gets damaged if the reverse current above a certain value is passed through it. This certain value is called the breakdown voltage. The breakdown voltage of a zener diode is very low, but this diode allows the reverse current to pass through it. Once this breakdown voltage is exceeded, that breakdown voltage is called a zener voltage. Hence, there is a controlled breakdown which does not damage the diode when a reverse current above the zener voltage passes through a zener diode. A zener diode, in its reverse bias, exhibits a controlled breakdown voltage, and it allows the current flow to keep the value of voltage across that zener diode close to the zener breakdown voltage value. This value of zener breakdown voltage makes any zener diode to be chosen for certain applications. Applications of zener diode. This diode has many applications, such as it is mostly used as a voltage regulator, provides fixed reference voltage in transistor biasing circuits, for peak clipping or limiting in wave shaping circuits, as a surge protector in many circuits, and for meter protection against damage from accidental applications. Switching. This is a normal single PN junction diode which is especially designed for switching purposes. This diode can exhibit two states of high and low resistance, clearly, which can be used alternatively. The junction capacitance of this diode is made very low so as to minimize other effects. The switching speed is made quite high. When the diode has high resistance, it works as an open switch, and it acts as a closed switch during low resistance. This transition occurs at a faster rate in switching diode than in any ordinary one. Applications of switching diode. These have many applications, such as use in high-speed rectifying circuits, use in ring modulators, use in radio frequency receivers, use as reverse polarity protectors, and use for both general purpose and high-speed switching applications. There are few diodes which are designed to serve some special purposes. There are many of such kinds like transient voltage suppression diodes, gold dope diodes, super barrier diodes, point contact diodes, Peltier diodes, and etc. But other than these, there are few prominent diodes which have got many applications. Let us go through them. Varactor diode. If the reverse voltage applied is increased, the width of the dielectric region increases, which reduces the junction capacitance. When the reverse voltage decreases, the width of the dielectric decreases, which increases the capacitance. If this reverse voltage is completely null, then the capacitance will be at its maximum. Though all diodes have this junction capacitance, the varactor diode is mainly manufactured to make use of this effect and increase the variations in this junction capacitance. Applications of varactor diode. This diode has many applications, such as it is used as a voltage variable capacitor, it is used in variable LC tank circuit, used as automatic frequency control, used as frequency modulator, used as RF phase shifter, and used as frequency multiplier in local oscillator circuits. Tunnel. If the impurity concentration of a normal PN junction is highly increased, this tunnel diode is formed. It is also known as Schottky Diode after its inventor. When the impurity concentration in a diode increases, the width of depletion region decreases, extending some extra force to the charge carriers to cross the junction. When this concentration is further increased due to its less width of the depletion region and the increased energy of the charge carriers, they penetrate through the potential barrier instead of climbing over it. This penetration can be used as tunneling and hence the name tunnel diode. The tunnel diodes are low-power devices and should be handled with care as they easily get affected by heat and static electricity. Applications of tunnel diode. There are many applications for tunnel diode such as use as a high-speed switching device, use as a memory storage device, use in microwave oscillators, and lastly, use in relaxation oscillators. Schottky. This is a special type of diode in which a p-n junction is replaced by a metal semiconductor junction. The p-type semiconductor in a normal p-n junction diode is replaced by a metal, and an n-type material is joined to the metal. This combination has no depletion region between them. The following figure shows the Schottky diode and its symbol. The metal used in the Schottky diode may be gold, silver, platinum, or tungsten, and etc. As well, for the semiconductor material other than silicon, gallium arsenide is mostly used. There are many advantages of Schottky diode, such as it is unipolar device and hence no reverse currents are formed, its forward resistance is low, voltage drops are very low, rectification is fast and easy with the Schottky diode, and there is no depletion region present, and hence no junction capacitance, so the diode gets to off position quickly. There are many applications of Schottky diode, such as use as a detector diode, as a power rectifier, use in RF mixer circuits, use in power circuits, and use as clamping diodes. Optoelectronic. These are the diodes which are operated on light. The word opto means light. There are types that conduction depending upon the light intensity and other type whose conduction delivers some light. Each type has got applications of their own. Let us discuss the prominent types among these ones. Some diodes conduct according to the intensity of light falls on them. There are two main types of diodes in this category. They are photodiodes and solar cells. Photodiode, as the name implies, is a p-n junction which works on light. The intensity of light affects the level of conduction in this diode. The photodiode has a p-type material and an n-type material with an intrinsic material or a depletion region in between. This diode is generally operated in reverse bias condition. The light, when focused on the depletion region, electron-hole pairs are formed and the flow of electron occurs. This conduction of electrons depends upon the intensity of light focused. Advantages of photodiode. Photodiode has many advantages such as low noise, high gain, high speed operation, high sensitivity to light, low cost, small size, long lifetime. There are many applications for photodiode, such as character detection. Objects can be detected, visible or invisible, use in circuits that require high stability and speed, use in demodulation, use in switching circuits, use in encoders, and lastly, use in optical communication equipment. Solar. The light-dependent diodes include solar cell, which is a normal p-n junction diode but has its conduction by the rush of photons, which are converted into the flow of electrons. This is similar to a photodiode, but it has another objective of converting maximum incident light into energy and storing it. A solar cell has its name and symbol indicating storing of energy, though it is a diode. The feature of extracting more energy and storing of it is concentrated in the solar cell. A solar cell concentrates on delivering high output energy and storing the energy. This has high capacitance value. The operation is a bit slower than photodiode. According to the purpose of a solar cell, the area of incidence of light is larger than photodiode. There are many applications for solar cell, such as science and technology, used in solar panels for satellites, telemetry, and remote lighting systems, and etc. In commercial use in solar panels for storage of electricity, portable power supplies, household uses such as cooking and heating using solar energy, and in electronics, which are watches, calculators, electronic toys, etc. LED. This one is the most popular diodes used in our daily lives. This is also a normal p-n junction diode, except that instead of silicon and germanium, the materials like gallium arsenide and gallium arsenide phosphide are used in its construction. Like a normal p-n junction diode, this is connected in forward bias condition so that the diode conducts. The conduction takes place in an LED when the free electrons in the conduction band combines with the holes in the valence band. This process of recombination emits light. This process is called as electroluminescence. The color of the light emitted depends upon the gap between the energy bands. Advantages of LED. There are many advantages of LED, such as high efficiency, high speed, high reliability, low heat dissipation, larger lifespan, low cost, easily controlled and programmable, high levels of brightness and intensity, low voltage and current requirements, less wiring required, low maintenance costs, no UV radiation, and instant lighting effect. There are many applications for LED, such as in displays, especially used for 7-segment display, digital clocks, microwave ovens, traffic signaling, display boards in railways and public places, toys, in electronic appliances like stereo tuners, calculators, DC power supplies, on or off indicators in amplifiers, power indicators, in commercial use, infrared readable machines, barcode readers, solid-state video displays, and in optical communications, in optical switching applications for optical coupling where manual help is unavailable, information transfer through FOC, image sensing circuits, burglar alarms, in railway signaling techniques, and door and other security control systems. Laser. Laser diode is another popular diode for its kind. This is an optical diode which emits light but with stimulated process. The name laser implies light amplification by stimulated emission of radiation. Stimulated emission. This is a p-n junction diode whose action starts when a light ray is incident on it. With a light ray, when photons get incident on an atom, the atom gets excited and it reaches an upper level which can be termed as a higher energy level. Atom, when shifts from the higher energy level to a lower energy level, it releases two photons which are similar in characteristics to the incident photon and are in equal phase to it. This process is called as stimulated emission. An atom can generally stay in this excited state for 10 to 8 seconds of time. So ayun, dito po nagtatapos ang lesson for today. Look forward to the next lessons and stay safe always. Thank you for watching.